this is my project. You can see this is dashboard, the state of sales forecast, and you can see this is the UI, and you can see these are the model, and my project will choose best model. So let's start. I built an end-to-end time series forecasting system that predict the next 8 week of sales of each US state. Four models training in parallel. The data picks the winner. The prediction are served by fast API. And let me show you. And you can see this is the fast API. And here you can see uh, these are the routes, sketch, and post. And on the route you can see here post route. Okay. And the data set has 8,000 rows of weekly beverage sales across 43 US states with irregular reporting and missing dates. The system needs to clean that and train four models on there. Per state, Sarima, Frostbite, and XGBoost with engineered-like features, and an LSTM. Auto takes the best one and server forecast through an API. I built it is real backend service and layered architecture, typically schemas and structural logging unit test for leakage prevention, not a notebook dump. And you can see this is the flow diagram. Here you can see raw text I type and then data loader and then preprocessing and somehow PyTest suite and feature engineering and model training on Serena Phosphate and XGBoost and use some metrics MAPE, RMSE and MA and model selector and load all the train model in artifacts folder, then connect to FastAPI and then Next.js dashboard. And, uh, and the most critical part of this assignment is feature engineering. So I wanted to highlight three things. First, lag features at T-1, T-2, T-4, and T-8 weeks. And rolling means and standard derivation at 4 and 12 week windows. Calendars feature for day of weeks, months, quarter, week of years, weekend, and month boundaries. And holidays flag from US mission calendar. And second, this is what separate production code notebook. Every rolling computation call shift one before rolling. And so the features for time t never see at a time t. And each of four models implemented the same base forecaster interface, feed forecast, save and load. So they are interchangeable from trainer perspective. Sanima does a small AI grid search over the sessional order. Phosphate use the multiplicative seasonally with US holidays and attributes train on the engineered features and forecast successfully one step at a time. And LSTM is a sequence to a network with early stopping and minimized scale output. And the API is first API with full OpenAI documentation, 5 endpoint, health, list, state, get models for state generate and forecast trigger training. This is currently forecasting. And here is the live forecast of California. The API load the fitting LSTM model and return 8 week of prediction plus recent history of context. Now let's go on dashboard and now run the code and dashboard on. This is based on Next.js and this is the dashboard. Now you can see it is forecasting the next 8 weeks of data. And the front end is Next.js 14 dashboard style like financial newspaper. And this is, you can see this is the Next.js forecasting, and this is the one you can see lower MFP is better. You can say LSTM is finished. Uh, you can say and you can see the prediction of Alabama and the type for our full project is working. And across all 43 state, average validation MAP was 3.62%, and this single state MAP was were not at 0.44. The California was there the most data LSTM won the 2.8 percentage and beating the XGBoost, and Prospect and Serima is that order. And the full repo is done locally, and you can read my documentation file, and I will add documentation. And thank you.